Moving on to the 15th question. In equilateral triangle ABC, D is a point on BC such that BD is equal to 1/3 of BC. Prove that 9 times AD square is equal to 7AB square. Now moving on to solution. Let us consider an equilateral triangle ABC in which BD is equal to 1/3 of BC. So let us join AD here. As it is a equilateral triangle, we can say that AB is equal to BC is equal to CA. So in order to prove the required proof that 9AD square is equal to 7AB square, let us draw AP perpendicular to BC. Now let us consider in triangle APD, which is a right angle triangle. By applying the Pythagoras theorem, we get hypotenuse square, that is AD square, is equal to AP square plus PD square. Now again in triangle ABP, by applying Pythagoras theorem, hypotenuse square, that is AB square, is equal to sum of square of other two sides, that is AP square plus BP square. Now let us subtract both the equations in order to eliminate AP square. Then we get AD square minus AB square is equal to PD square minus BP square, which implies, let us make subject as AB square, then we get AD square plus BP square minus PD square. Now let us consider the two triangles, that is triangle APB and triangle APC. In these two triangles, angle B is equal to angle C and angle APB is equal to angle APC. Therefore, by AA similarity, we can say triangle APB, triangle APC. So we know that when two triangles are similar, then their corresponding sides will be in proportion. Here AP by AP will be equal to PB by PC will be equal to AB by AC, which implies AP by AP is nothing but 1 and AB by AC is nothing but also 1, because in equilateral triangle all the sides are equal. So we can say that PB will be equal to PC, that will be equal to half times PB, that is equal to half times BC. So this is in order to prove that PB is equal to half times BC, that is equal to AD square, let it remain as it is, and BP, as AP is an altitude, we can say that it bisects BC perpendicularly. So half BC whole square is nothing but BP square minus PD square. Then the equation becomes AB square is equal to AD square minus PD square plus BC square by 4, which implies AB square is equal to AD square minus, here we can write PD as BP minus BD whole square. Here we are also left out with BC square by 4, which implies AB square is equal to AD square plus, let us write the BC square by 4 here, plus minus BP minus BD whole square, which implies AB square is equal to AD square, let it remain as it is, plus BC square by 4 minus, let us expand in the form of A minus B whole square, that is A square plus B square, and here minus into plus is minus again, BD square plus minus into minus of 2AB, that is plus 2 into BP into BD, that is equal to AD square plus BC square by 4. We know that BP square is half of BC, so that will be again half of BC whole square, which is nothing but BC square by 4, minus, we know that BD is equal to 1 by 3 times BC. Let us replace it, 1 by 3 times BC square plus 2 times BP is nothing but half BC, and BD is nothing but 1/3 of BC, which is equal to AD square plus BC square, and minus BC square by 4 will be cancelled. And now let us write this term here, then we get BC square by 3, as here 2 and 2 common in numerator and denominator will be cancelled, minus here 1 by 3 BC square is nothing but BC square by 9. That implies AB square is equal to AD square plus BC square by 3 minus BC square by 9 is nothing but, let us take 9 LCM here, then we get 2 BC square by 9. That implies, let us cross multiply with 9, then we get 9 AB square is equal to 9 AD square plus 2 BC square. That implies 9 of AB square minus 2 times BC square is equal to 9 AD square. That implies 9 AD square is equal to 9 AB square minus 2 BC square. In equilateral triangle we know that BC is equal to AB. 9 AB square minus, we can write BC as AB, then we get 2 AB square. Finally we get 9 AD square is equal to 9 AB square minus 2 AB square is nothing but 7 AB square. This is what the required proof for us.